Okay, in this section, we're going to be looking at fractions, but before we do that, we need to go back and look at a couple of definitions. The first definition is prime, and a prime number is a number that has only two factors, one and itself. For example, the number 2 is prime, and so is the number 3. A composite number is a number that has more than two factors, for example, 9 or 16. And one thing I want you to notice here is that 9 is odd. So just because a number is odd does not necessarily mean that it is prime. And also note that the number 1 is neither prime nor composite. Now here are the directions for our first two problems. Determine if each of the following is prime or composite. And we're given some hints here. It says we can use our divisibility rules to help us figure this out. So if you remember your divisibility rules, if a number is divisible by 2, then that means it's going to end in 0, 2, 4, 6, or 8. It's an even number. A number is divisible by 3 if the sum of the digits is divisible by 3. For example, if you have the number 45, I can add 4 plus 5 and get 9. And since 9 is divisible by 3, 45 is divisible by 3. And if a number ends in 0 or 5, it's divisible by 5. So looking at our first number, 32. This is an even number, so it is a composite number. Now the number 17 is not going to be divisible by 2, 3, or 5, so it doesn't follow any of these rules, but we still need to check other numbers, like maybe 7, see if that will go into 17 evenly. So, you can divide by 2, 3, 4, 5, 6, all the way up to 16 and see if any of those numbers go into 17, and none of them do, so 17 is prime. Okay, the directions for our next two problems say to find the prime factorization of each of the following, and there's a hint is to use the divisibility rules to make a factor tree. So there's several different ways that I can start off this factor tree for 30, but I'm going to be sort of consistent in how I do this. And I'm going to start with the smallest number, which is 2, right, because we never use 1 when we're using factor trees. And I'm going to see if 2 can go into 30. And it can. So 2 goes into 30 15 times. And I know that 2 can't go into 15, so then I move up to the next number, which is 3. And I know 3 can go into 15 5 times. So the prime factorization of 30 is 2 times 3 times 5. Now I want to stop here for a second and point out that it's important that you read the directions in my math lab to figure out exactly how they want their answer entered. If you put the answer is 2, 3, 5, my math lab is going to count that wrong. Right? So don't do that. Be sure you're using the multiplication signs. In problem 4, I want to find the prime factorization of 405. Now, the first thing I notice is that this number ends in a 5, so I know it's divisible by 5, so I'm going to go ahead and use that as the first branch in my factor tree. And I'm going to come over here and do long division. 5 can't go into 4, but 5 goes into 40 8 times. So I have 8 times 5 is 40. Subtract, I get 0, bring down the 5. 5 goes into 5 one time, so this is 81. And I know 81 is 9 times 9, and the 9s can break down into 3 times 3. So my final answer is going to be 3 times 3 times 3 times 3 times 5. Okay, problem number 5. Note that 25 times 3 is 75. So why is 25 times 3 not the prime factorization of 75? Let me give you a minute to pause the video and think about that. Well, the reason why 25 times 3 is not the prime factorization is because 25 is not prime. Okay, on your first test, you might have a problem that looks like this. Notice when I multiply my answer choices together, 25 times 3 is going to give me 75. 3 times 3 times 5 is 45. 3 times 5 times 5 is 75. So choice A multiplies to give me 75, and so does choice C. So you can't just look at these numbers here on the end to figure out which one is the right answer. You have to be sure that you have the prime factorization. All of the numbers that are being multiplied are prime. In choice A, the 25 is not prime, so the correct answer here is C. Okay, the directions for my next two problems are to simplify. And my solution, or the hint here, is to divide the numerator and the denominator by the GCF, or greatest common factor. So I want to find the biggest number that goes into 4 and 10. So the biggest number that goes into both of those is 2. So I'm going to divide the top number by 2, and I'm going to divide the bottom number by 2. So 4 divided by 2 is 2, 10 divided by 2 is 5. So my answer is 2/5. One thing I want to point out here is that it is wrong to do this. I'm not simply dividing this fraction by 2. This is something different than what we're doing. So this is wrong. So don't write it like that. Now, you don't have to put the division signs in there if you don't want to. If you just want to say 4/10 equals 2/5, that's perfectly fine. Let me give you a minute to try number 7 on your own. Okay, the biggest number that goes into 18 and 30 is 6. So you're going to divide the numerator and the denominator by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So your answer is 3/5. Now, if you happen to divide both of these by 2 first and get 9/15 and then realized, oh, I can still simplify that, both of those are divisible by 3, and then divided and got 3/5, there's nothing wrong with doing it that way either. Okay, the directions for our next problem say to change each of the fractions to a mixed number. And we are going to do that by using long division. 17 halves means 17 divided by 2. Right? So 2 into 17. 2 can't go into 1, but 2 goes into 17. 8 times. 8 times 2 is 16. Subtract, you get 1. So the answer here is 8. And go around this way. 1/2. So that answer is 8 1/2. Right, let me give you a minute to try problem number 9 on your own. Okay, the answer there is 3 3/5. Okay, the directions for our next two numbers are to change each of these mixed numbers into an improper fraction. So for problem 10, I'm going to rewrite this just so I can have it bigger. I have 3 2/5. So what I want to do is start with the denominator here of 5. And I'm going to multiply 5 times 3 and get 15. And then I'm going to add 2, and that's going to give me 17. So my answer is going to be 17/5. This denominator of 5 is always the denominator that we have over here in our original number. 17/5 is my answer. All right, let me give you a second to try number 11. So pause the video and see if you can do that one on your own. Okay, again, we're going to start with the denominator. 4 times 8 is 32. Plus 1 is 33. So the answer here is 33/4.